This video is going to talk about the difference between permutations and combinations, but the first thing I'd like you to do is pause the video after turning to page 7 and try the two problems on page 7. So hopefully you tried these two problems on your own. The first one says that we have a deli and there are different sandwiches. We can choose different side dishes and different beverages. And how many different lunch specials can we order? Well, there are 10 choices for sandwiches times 12 choices for sides times 7 beverages. When I multiply that together, I get 840 lunch specials. Mackenzie is setting up a display of 10 of the most popular video games from the previous week. If she displays the games side by side on a shelf, how many different ways can she arrange them? So there are literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. She's got this stack of video games. When she goes to the first video game, to grab the first one, there are 10 options. So there are 10 choices for the first spot. But then when she goes to get the second video game, there are only 9 video games left. And then 8, and then 7, 6, 5, 4, 3, 2, 1. And if we put that in our calculator, that's a lot of typing. We get different ways to arrange the video games on the shelf. Okay, so I'm going to just quickly show the answers from last night's homework. You can pause the video if you need to look at them more closely. Page 6. Okay, so today we are going to talk about 3 calculation principles: the factorial principle, the permutation principle, and the combination principle. The first one we are going to look at is factorial. And so at the top of page 8, it says key concept. The expression n exclamation point, read n factorial, where n is greater than 0, is the product of all positive integers beginning with n and counting backwards to 1. So you can see, for example, 5 factorial is 5 times 4 times 3 times 2 times 1. So the example with the video games on the shelf could be written 10 factorial, because we did 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And there's an easy way to calculate this on our calculator. We're going to write it down first, and then we're going to actually go to the calculator and look at it. And that is to get the factorial symbol. It does look like an exclamation point, but it's not. It's a factorial. And it tells us that we're going to multiply counting from 10 down to 1. We're going to go to math. We're going to go across 3 times. Actually, I don't like that arrow there, because it makes it look like we're using the up arrow. So to get that symbol, which we're going to go to math, and then we're going to go 1, 2, 3 to the PRB menu. That's the probability menu. And then it's number 4. So pause the video and write that down if you didn't already. Okay, so now we're going to go to our calculator. It doesn't matter what version you have, they all have the same menu. We're going to do 10 math, and see it says math, number, complex, probability. So we're going to go 1, 2, 3, and there it is, number 4, and it puts an exclamation point there. And when I press enter, I get the exact same answer that I got by multiplying 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1, which is 3,628,800. So we use factorials, please write this down, when we are arranging n objects and order matters. Meaning the order which you put people down or you put items down matters. I always give the example, if you're putting kids in a line, the order matters. Who the first kid is, who the second kid is. I mean, like, you might claim it might not matter, but if you ask a group of kindergartners, it matters who's in the front of the line, who's second. So if we're arranging all the objects, just like with the video games on the shelf, and order matters, and we're arranging everything, we're going to use 10 factorial. Now, let's say we're not arranging everything. Let's say we have some things we're arranging on a shelf, but we're not going to arrange everything. We're just going to arrange a few of them. That's called a permutation, right? A permutation, if you have n objects, everybody write this down. Oh, poop. Go away. N objects, order matters, and we are going to select, hope that I could spell, let's say, and we're going to select R, right? So let's say we have, oh my God, I keep touching too many things. Let's say we have 10 kids in a class, and we are going to pick 2 of them for, I don't know, line leader and the caboose. It's kindergarten. 10 is our end value. We would say 10 P2 because 2 is the number we are selecting. It matters who gets picked first and who gets picked last. Because if you're picked first, you're the line leader. If you're picked second, you're the caboose, and everyone else just gets in the middle. All right, so for that, we would do 10 factorial over 10 minus 4, or sorry, 10 minus 2 factorial. Now, the good news is that we don't really need to use this formula. We don't need to memorize it. There is a button on our calculator. We might have seen it before when we were using the factorial for permutations. And let's make a note here. We're going to go, first you're going to type the N. Then you're going to go to math. You're going to arrow across 1, 2, 3 to PRB again. And it is number 2 and PR. And then you actually are going to type the R. All right, so if I want to do 10P2 on my calculator, pause the video and write down the directions if you haven't already. To do that on my calculator, I'm going to go 10 math. I'm going to go over to the PRB menu. I'm going to select 2. Now, the N and the R are still going to be there. It just tells you what order things have to be in. And I'm going to put a 2 in. And I find that there are 90 ways. Okay, so now let's just try these on our calculator. Go ahead and type these in. I suggest you pause the video and then unpause the video and see if you get the same things I do. Zach and Kurt are going to an amusement park. They cannot decide which order to ride the 12 roller coasters in the park. How many different orders can they ride all of the roller coasters if they ride each ride once? So basically what we're doing is we are arranging how many ways we can ride these 12 roller coasters. So first, we have 12 choices, and then 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So this is a 12 factorial. And the reason I know that is because I have 12 coasters I want to ride. Ride them all. So like I'm selecting all of them. Order matters. I mean, because like you got to ride the best one first because otherwise the line gets really long. So let's go ahead. 12 math. 4. Ooh, that's a lot. 7. Okay. If they only have time to write 8 of the coasters, how many ways can they do this? So here, our n value, the total we're selecting from is 12. The number we are selecting is 8, and order matters. So we're going to do 10 P8. Sorry, I wrote 12. I don't know why I said 10. I meant 12. My apologies. So we're going to do 12 math. Oh, poop. 8. Okay. So again, these are all calculations we're doing when order matters. So like, let's say order doesn't matter. Let's say it doesn't matter what order we ride the roller coasters in. Then we're going, oh, wait, we're not there yet. The straw's got ahead of herself. The tennis coach has 4 players on his team. He wants to find out which players should be ranked and which second. Let's call the possibilities A, B, and C. So we have N is 4. He's got 4 players on the team, and we're going to pick 2 of them. And order matters because the first kid picked is first and the second is second. So like you could totally sit here and like write it down. A, B, B, A, C, C. That's too much. We have 4 kids. We are selecting 2 of them, and order matters. There are only 12 ways to do it. And again, you could be like A, B, B, A, C, C, A, D, D, A, B, C, C, A, I'm gonna space A. What are the other guys? So that's not an A. There we go. A. Wait. No, that was a C. Okay. AC, CB. We could have B, D, D, B. And then we could have C, D, D, C, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Yay. Okay. Now, oh, we got a few more tries before we talk about combinations. Well, that's probably good. We could use the practice. Pause the video, try these 3, and let's see if we get the same calculations. Again, you should be pausing the video and trying these on your own. Digit numbers. No, so we're selecting them. If we're not repeating them, like once we're selected, I can't. So I have 1, 2, 3, 4, 5. I have 6 numbers to choose from. I'm picking 2. Order matters. I'm going 6P2. Which is 30. Okay, now we're going to talk about combinations. So same situation, we're starting with n items. We're selecting R, so n total, R selected. But now order does not matter. They give you an example here. Let's say you're choosing 2 salad ingredients from a list of 10. It doesn't matter if you do tomatoes and cucumbers and tomatoes. It's going to be the same. So, and again, we don't really need to worry about the mathematical calculation because this calculation can be done on a calculator. So if we were doing 10 salad items and we were picking 2 of them and order doesn't matter, we would do 10, same thing, math, probability menu, but now it's number 3, pick 2, and there's 45 ways. So now the big thing here is going to be to decide whether or not the order matters. Is this a permutation or a combination? So the first situation is that we are selecting officers, president, vice president, and secretary from a 25-person PTA. Do you think the order people are selected matters? If you said yes, you are correct. This is a permutation. Order matters. The first person will be the vice president, the second the vice, the third the secretary. A cook chooses 5 potatoes from a bag of 15 potatoes to make potato salad. Does order matter? No, order does not matter. All the potatoes are going to get cut up and put in the potato salad. This is a combination. The teacher is making a seating chart for 22 students in a classroom with 30 desks. So you just have to be careful here. They're starting with the desk. This is our n value, and we are going to select 22 desks. Does order matter? Yes, if they fill the desks in order, like the first rows get filled first, the first kids picked get the first row desks. Order matters. Okay, on page 10, it says the students of Mr. DeLuca's homeroom have to choose 4 people out of 7 to nominate to serve on the student council. How many groups of students could be selected? So pause for a moment. Does order matter? Is there a benefit to being selected first? If you said no, you are correct. Order in this situation does not matter. Because order doesn't matter, we're going to use permutation. We have 7 people to choose from. We are picking 4 of them. So we're going to do 7C4. 7C4. We have 35. Okay. So what I'd like you to do is I just want you to pause the video. You don't need to complete the calculations. I want you to just read the next situation and make a decision. Is this a permutation or is it a combination? If you said it's a combination, you are correct, because the fight doesn't matter if you're the first finalist or the 10th finalist. So here we have 51 contestants and we're choosing 10 of them. 51, choose 10. Whoa, and there's a lot. So let's talk about this number. If I've got 1.2, let's just go with 1.3. Now, when I see that E, that's like times 10 to the power of, there's a 10 here. So when I read this E, it's times 10 to the power of 10. This is scientific notation. Go ahead, pause the video and just try these 3 calculations. This should be the result of your calculations. If anyone's wondering about letter B and why the 0 factorial is 1, let's think about it. Here I have 3 items that I'm arranging all of them in a unique way. So that will be 3 times 2 times 1. Here I have 0 items. I'm arranging them all 0 items in a unique way. How many ways can I arrange 0 items? If you said 1, you're correct. 0 factorial is 1 because there is 1 way to arrange 0 items. So while you might think that should be 0 times 0, because this notation is really used for arrangement of items for the multiplication rule of counting, like an offset, 0 factorial is actually 1 because there is 1 way to arrange nothing. Homework tonight is to page 11. Please make sure you read the directions carefully, and you can check your answers online.